If you were to travel to the Cascade region of Oregon up north, you may notice a certain number of trees that are nothing more than withered trunks. Now, you can blame forest fires or intense logging, but the real answer is the work of a splinter cat. Splinter cats are ferocious nocturnal felines whose main source of food are raccoons and bees. How do they get the raccoons and the bees? Not by setting traps. Why, they do it why any ferocious nocturnal feline would. They approach the tree at top speeds and ram it with their heads, shattering the trunk into it's nothing but a withered husk of itself, so they can then consume the raccoons and bees they shook out of it. However, since they are always ramming trees with their heads, they have horrible headaches and are always in foul moods, and so you should never, ever approach a splinter cat in the wild. Thankfully, we have one here with us today that I just gave just like a boatload of Motrin to. And we are very happy to have her. Please put your hands together for Paige Bernier.
Hi. Okay, I think we're good. You can hear me. Thank you for that. Not too far off the mark, as I did have wisdom teeth surgery a week ago today. Welcome to my talk, Disposable Infrastructure. You only build me up to tear me down. I'm Paige, and you can find me on Twitter as alpacatron3000. So a little bit more about me. I majored in engineering management, which was an odd combination of mechanical engineering and business. From there, I got involved with the Startup Weekend community as a participant, winner, organizer, all of the above. And that led me to tech, which led me to New Relic, where I've been for the past 2.5 years. And at New Relic, it's really where I learned about DevOps and started to DevOps myself. And that led me here today. This slide was supposed to be a snarky. I'm from Phoenix, Arizona, and air conditioners are great. But in light of the heat wave, it's a little bit mean, so I'll just say air conditioners are my favorite invention. Please use them this week. This is my kitten, Norman. He is very adorable, and if you want to have an open space to talk about how adorable he is, please come find me anytime, anywhere. So, here we are. What I'm going to talk about today is what is disposable infrastructure. We'll define it by what it is and what it isn't. I'll then move on to how it's done, the stack that my team chose, the tools we chose, and the wrapper tool that we wrote to leverage disposable infrastructure. And then I'm going to finish up with why you should try it. So, what is and what isn't disposable infrastructure? I'm going to tell you a tale of two versions of the project that my team has been working on or is in charge of. Version 1 was not built using disposable infrastructure, sort of the more traditional long-running model, long-running server model. A lot of our time is spent debugging the services and the infrastructure bugs that pop up. And all of the incidents that we've had since I've joined the team have been infrastructure-related incidents and have taken up a lot of our time. And it's really distracting us from building the V2. At the time I joined, you could only set up a V2 and deploy a V1 environment with one Jenkins job. You couldn't do it from your box. It is not very portable. So that's V1. I'm sure you can imagine V2 is a lot better, which is what I'm here to talk about today. V2 you can spin up using our CLI tool, as long as you give it the right accounts to spin it up to. Super easy, from your box, from the Jenkins box, whatever. It's very portable. I'll talk a lot more about that. You basically just give someone your state files and securely share your credentials, and they can spin stuff up, spin it down. And it gives you reproducibility, the same exact environment if you're giving it the same config file. So breaking down disposable infrastructure. Disposable, according to my fancy Google search, means intended to be used once and then thrown away. Obviously, in the case of software infrastructure, we're not going to be throwing away these servers. But what it really means is we're going to spin up this server as long as we need it, and then we're going to take it down. So that's the first intro part. It does not mean having like super long running servers, and this is one of those, like, there's not one answer for everything. I can't tell you how long you need to have this to make it a disposable infrastructure, but really, it depends on how often you're pushing out updates. And I'll talk about how my team does it. Moving on to the second word, I'm pretty sure I don't need to define that for this crowd. But if you were curious, Webopedia defines it as the collection of hardware and software used to develop, test, operate, and monitor services. According to me, disposable infrastructure is automating the process of provisioning, configuring, and destroying infrastructure. I'm going to spend a little bit of time on this slide just so I can get everybody acquainted with this concept. So for us, we tied our application deployment to our infrastructure deployment. So for us, it means 0 to live running servers with our applications and back down to 0 again, that entire life cycle. But that's not necessarily disposable infrastructure. Really, disposable infrastructure would be 0, live running infrastructure back to 0 again. It's that whole life cycle that's done with like one click of a button. So this is disposable infrastructure. What is it not? I tried to make this asterisk as big as possible, but it doesn't quite translate. It's not necessarily immutable infrastructure. This I liken a lot to how all squares are rectangles, but not all rectangles are squares. So immutable infrastructure is by its definition disposable. If I'm going to bake my service into an AMI and deploy that, and then the next time I add a new feature, I have an update, I bake a new AMI, take what's down, and deploy the new service out there. That is disposable infrastructure. You can also have disposable infrastructure that is mutable. So in the case of my team, we don't bake our AMI. What instead we do is we send up, we have our install and we have our deploy configuration. We send up our files through an Ansible playbook. So if we're going to add a new feature, we don't necessarily have to tear everything down. But we have the ability to do that, and that's what makes it disposable for us. So squares, rectangles, not necessarily immutable, but immutable is. So the second part is there's, as adorable as I find the phrase pet or snowflake servers, disposable infrastructure really incentivizes you to do the right thing and make the changes to the config, because how it's set up, and depending on how often you guys are deploying, you're not incentivized to make changes on the servers that are running, because at any point someone could do a redeploy and blow away those changes, or they could take it all down and be spinning something new up. So you're not guaranteed that what you are changing out in the wild is going to stay. So it really disincentivizes the whole pet and snowflake server thing. So that's what it is and what it isn't. I'm going to move on to how my team does it in the tools that we chose. So I think disposable infrastructure has a nice, cozy home here in the land of DevOps. A little bit of background about my team. We're all software engineers. Our titles are software engineers, and nobody on the team is like a dedicated ops person. We're on call for our services. We build and deploy them. But what we're really on the hook for is like what we're developing. So as we approached V2, we thought, V1 has all these problems. It's really tricky to maintain. What's a system or a tool set that we could put together so that the ops part is a little bit easier for us? So with disposable infrastructure, there's wonderfulness. So what we built was a CLI tool called Infratron. We are talking about open sourcing it. It will be a very long path to actually doing that, but stay tuned. And Infratron is a wrapper tool around the provisioning and configuration management tools that we chose. So it combines them, so you have a one-click deploy, provisions, configures, and then for us, also deploys our applications. At a high level, this is what I believe the disposable infrastructure deploy workflow looks like. If you have the wrapper tool, first you're obviously going to parse the config, the sort of master config. Then you move into provisioning, configuring, and what I find important is sort of verifying that everything got set up and hit your health endpoints, and then packaging your state files. This one was really important because as we were actively developing and redeploying and stuff, we weren't keeping track of our state files super well. And when you lose your, I'll talk about the tool we chose. When you lose your .tf state file, you have to destroy everything by hand, and that is not fun the first time, the second time, or the fifth time. The destroy is pretty simple. You can just tear everything down with one click as well. And so I'll get into the tools that we chose next. At the project kickoff, we had a lot of healthy discussion and debate about what tools to use. And we looked at a lot of the big players in the IT automation spaces. Early on, we decided against the master agent setup as we had a pretty small deploy footprint, and we wanted to, it just didn't make sense for us. also important to us was that we were cloud provider agnostic. We didn't want to build out a custom tool just for AWS, only down the line to hear that Azure or GCP was going to be the new thing that we needed to work around. So we can have all of the clouds with the tools we chose. We wanted to make it easy to share environments. This way we could deploy an environment for somebody, and they could make the updates or changes they needed, but we could always have the ability to spin stuff back down. And then for us, our third sort of thing we were looking at, our criteria, was to have a full deploy in under 10 minutes. And for us, we're deploying about 13 services at a time, so this was pretty doable. First, we chose AWS, and I say chose, which is probably not the right word because our SRE org gave us an account that was already hooked up to central billing. And as much as I love my team, I was not about to put like our infra costs on my credit card. So AWS, it was. Secondly, for provisioning, we chose Terraform. And thank you so much, Terraform engineers and HashiCorp. This is a wonderful tool. You feed Terraform a .tf file that lists the amount and type of resources you'd like to create for a given provider. And for my team, it's AWS. And we are deploying a bunch of EC2 instances, ELBs, domains and subdomains, security groups, all of that stuff. And if you're not familiar with Terraform, I took a block defining an EC2 instance just to show you how simple it is. Pretty easy to figure out. So here, you can see we give it an AMI ID. I definitely have a slide talking about the AMI part of things. You give it an instant type. Depends on is pretty important because you can't have the EC2 instance without being attached to a security group. So this just lets Terraform know that you've thought about that and it's in the .tf file. Tags. I'd be super curious to hear about how other organizations tag and what tags are important to them. So maybe let's talk about that later. And then our security groups, your PEM key name for the region you're deploying to, and then the count of how many instances you want. So now I'll talk about the Terraform workflow. Terraform plan is probably my favorite. This will list what actions Terraform would do to get your infrastructure to match your .tf file. It's pretty simple to do, just a Terraform plan, and this really makes things safe. You know exactly what Terraform would do. There's no surprises there, and you can kind of get a preview. The next part is the apply. This will mean that Terraform actually performs the actions in order to get your desired infrastructure. The cool part is you can pipe a Terraform plan into a Terraform apply, so you're only making the changes that you sort of know and can check off on. Definitely a nice peace of mind, especially when you have one button that sort of does all of the things. And this is not a part of the Terraform workflow, but I personally really enjoy this feature, and I'm on the stage, so I get to tell you about it. Terraform graph. This will create a visual dependency graph of your infrastructure, which I find amazing. I'm a very visual learner, so I can just show you the example right now. What you see here is we have the provider for AWS. We've got 3 instances of one EC2 instance named test, and then we've got it hooked up to an ELB and some Route 53 stuff. And it's really nice if you're walking into a new setup to get a lay of the land and see what's going on, or if you need it for documentation. Super handy because you don't have to do all the boxes and arrows yourself. Terraform graph is wonderful. My one note about it is it gets very horizontal. So if you have a pretty complex deploy story, which I'm sure most of us do, you need like a super big monitor or you're like scrolling for ages. So maybe like they could work on that. But everything else is amazing. So that's Terraform. That's our provisioner. We bring in Ansible, a provisioning and configuration management tool by Red Hat. You'll see that I bolded configuration management tool. As we were deciding what tools we needed to use, we thought that there's a nice separation of concerns to have Terraform do our provisioning because that is what it does best. That is like what it is here for. It's what it's built. We bring in Ansible for configuration management because it is really good at that. So this is Ansible. If you're not familiar with it, the Ansible configs are called playbooks, and they're written in YAML. I do have a slide about that. And the thing that I find super helpful about these is you can tag the tasks. Ansible playbook is made of tasks that you run to configure things. And what we have done, because we have coupled our app deployment with our infra deployment, is we have a set of tags that are install, that installs all of our dependencies. And then we have a deploy tag that deploys all of our services. And I will talk later about why it's important to differentiate between those two if you are going to couple your disposable infrastructure with your app deployment. So Infratron that we built I'm going to do a little bit more of a deeper dive into what happens when we do a deploy. We're parsing our config file, and we generate a .tf file. And from that .tf file, we run a Terraform apply. And then from the .tf state file that got created with, like, here's all the things I did and I made for you, we grab the public IPs for the instances, and we write those to an Ansible host file. Then we run our Ansible playbook. If it's a first-time deploy, the install and deploy tags. And then, again, my most favorite part is the verify. We just hit all of the endpoints to make sure that all of our services are healthy. We have an API endpoint that'll say, like, blank services healthy smiley face, which is always kind of cute to see. And then finally, packaging. We actually package our Ansible playbooks, our host file, and our .tf state file in the case of somebody needing to make a change or redeploy a service. It's nice to just have everything all bundled up together. So the main flags that we have, I said it's a CLI tool because in the beginning we were deploying from our boxes before I set up our Jenkins stuff. And our main flags are the deploy, the redeploy, and the destroy. The redeploy one, I'll spend just a quick second on. It's important for us because we're doing the mutable infrastructure. And so we can save a lot of time by cutting out the Ansible install tasks. That can take a while. And then instead of running another Terraform apply, we just run a Terraform plan and look at the output of that. So if Terraform tells us there's nothing left to create, we don't need to go through all of the rigmarole of it checking everything. So redeploy, really handy if you're going to do the app deployment as well. So I wrote a beautiful haiku for you all. It is syllabic. It makes sense. I wrote a config that leads to a new config. Why? Because YAML. And I posted this on Twitter, and my friend Britt said, oh my God, please no abstraction hell. And so I'm here to tell you why I think it is important to have a config for a configuration management tool. Something that I laughed a lot about when I was tasked with looking at this. So this is my justification here, and I hope Britt will watch this later. First, I get to avoid YAML and DSLs in my day-to-day. This is, for me, the biggest selling point. I think for you all, number 2 will be the biggest selling point. But for me, I get to write a config that my team came up with in a way that makes sense for us. And yes, we had to deal with YAML and DSLs in the beginning to get our tool set up. We basically have a bunch of generator functions. So if in our Infratron config, we ask for an EC2 instance with our Java web app on it, it's going to know that it needs to take one EC2 instance, a security group, an ELB if there's more than one, and then what service to put on it. I don't like writing .tf files, and I don't like writing Ansible playbooks, so for us it's really nice to have that layer of abstraction, especially when coupled with the app deployment. And number 2, you get to define what makes sense for your needs and for your project's needs and their service needs. We originally decided to do one app per host, and now we're deciding to do multiple apps per host. And because we're sort of at this higher level and we have these generator functions, it's pretty easy for us to mutate it in that way. Up next, we're doing containers, and because we have sort of this baseline, it's a really nice place to go from. So I hope you are convinced that you should have a config for a config. You can talk to me about it later. This is an example of our one service running on one app. You just see we're asking for an instance type, we're asking for a count, and then what service you want to have on it, and we tag it. So this is my demo. It's not a live demo because it would be 10 minutes of looking at a terminal output, which is not super exciting. It all begins with the deploy. And I will say, if you can't read this, it's OK, because I'm going to be telling you what's on there. The deploy leads us to parsing our file, and then we generate our Terraform file. We do the deploy. We start the Terraform apply. And then Terraform outputs something like this for every resource it creates. You can suppress it, you can log it, whatever, but make sure you have a dev mode where you can see all of the things. It's really handy. And then this is Terraform telling me, like, yay, I made 11 resources, nothing changed, nothing was destroyed, and then like I gave you a .tf state file. Great. A gotcha for you is that sometimes Terraform says, I'm done, and we move on to writing the public IPs to the Ansible host file to configure all of our things, and things are not quite ready yet. The instances are still maybe initializing, or I'm not actually quite sure, but And then we have a failure. So what we do is we ping and make sure all of our services are responding to HTTP requests, and then we run our Ansible playbook. So you get that one for free. You're welcome. This is what the Ansible output looks like if you're curious. There's stuff that I'm sure you guys have to put on all of your servers. So we have a playbook that just runs through the setup that we need on everything. And then the service-specific stuff, as you can see. And here, the important part, our tool will output the endpoints of the services it created, and then it times itself because our metric was under 10-minute deploy. And you can see here, we did it in 9 minutes. Pretty lovely stuff. And then for the teardown, that goes a lot faster. That was done in 1.23 minutes. That's pretty great. I will say if you bring databases into the picture, which we do for our full deploy, but I didn't do for this demo part, that adds about 2 to 3 minutes. I was super sad about that because we were running really fast for a while. But you need databases, so just know that. So a big question that I grappled with a lot was for our AMIs, or machine images. Do we bake them or not bake them? And there's sort of a list of questions that I came up with, and I'm pro and con baking your AMIs. So is your service mature enough? Have you not changed your dependencies in a while? Do you know this is going to be set? Your dependencies are kind of stable, the service is mature, not a lot's going to be changing? Bake an AMI. How many instances are involved? If you're doing large-scale deploys, maybe you do want to save this time and bake the AMI yourself. And then, are you ready to change your deploy story? Right now, the way it is with running the Terraform and the Ansible commands, that's it. Like, you have the whole environment and ecosystem like in one little contained unit, and that is very beautiful. When you bring in a new deploy story, you're asking yourself, when do I bake my AMIs? How am I setting this up with like Jenkins? Are we ready to add this? What's the story here? And so it adds a lot of complexity. But I think in certain instances, it will save you a lot of time, and I do think it's worth it. HashiCorp also has a tool called Packer, which is fantastic, and I played around with it if you are curious about baking your AMIs. So I'm very pro and con, and like most things in engineering, like it depends on your setup. So gotchas. Testing this tool is pretty tricksy. You can do the unit test. You can figure out what you're passing to Terraform and Ansible and make sure that it is the right thing. But the tool itself is, like, Ansible and Terraform are out in the wild. They're doing the things. We can't necessarily test that. And that's not my favorite thing to kind of come to terms with. But like an example that I have is we did our unit test. Everything looked fine. I'd been doing deploys by hand. We were really like thorough about this. I set up our Jenkins stuff. First time deploy, so excited, right? And Ansible hangs on me. It's just like spinning. I've never seen this before. Like, what is happening? I've probably done like 200 deploys from my machine. You just can't like test for that kind of stuff. So, or if you can, please come tell me because I'd love to know. Gotcha's testing a little bit tricky. Terraform is a little bit of a baby. It's not at V1 yet. I'm running 9.5, which means it's got most of the functionality I need covered. Once in a while, you'll run into an interesting case where you will need to write a script to sort of cover that, or I'm sure they would love if you would contribute because it is an open source project. But just know that if you're going to use at least our stack, it's a little bit newer. I do have an example of that, but I'm not quite sure on the whole time thing. Windows. We had a Windows developer on the team. We got one. And none of us have Windows machines. We're like an all-Mac shop, pretty much. And the tools we chose can provision and configure Windows instances, but running them on the Windows machine was a little bit tricksy. So another gotcha to think about if you are a Windows shop.
You have 8 minutes, so you're fine.
Oh, 8 minutes. Cool. Lie. This is like the worst picture that I chose. I was getting a little bit late. But like I said, Terraform will release the instances and say, like, yeah, I did it. And then if you immediately run into your Ansible play, it's not quite ready. So just know that the timing of things is something that you have to manage if you're going to write this wrapper tool. And then finally, please exit early. With something like this, if you fail early, if Terraform fails or something is not provisioned correctly, you're going to get a lot of weird errors down the line. And you may as well just exit as soon as you have the first weirdness or errors. So exit early, please. So we've done what is and what isn't disposable infrastructure. I've shared how it's done. And now I'm going to finish up with why you should try it. The case for disposable infrastructure. I think one of the most interesting use cases is that you can use it to track down customers' bugs. Customers run all different versions of whatever software or agents you have, and it's really nice to be able to spin up the exact stack that the customer is running on with the exact version and reproduce that environment exactly. Second, not for testing itself, but for testing new features. If you don't want to do the feature flag thing, you could just spin up a new copy of everything with your new code that you're testing out and have people come beta on it. I think that's another great use case. And then the use case that my team has. We're a team of engineers, but we're also on the hook for the services we write. We're in charge of maintaining them. And so disposable infrastructure really gives us the peace of mind that we can focus on developing and that our ops story is pretty good and solid. So I'll leave you with 3 pros of disposable infrastructure. It's config-driven, which I think is beautiful because your config is your word. It lays out what your desired infrastructure is, what you want it to be configured with, and you can't rely on changes that you make in the field to persist. You just can't. It also means you've got a little bit of documentation about your infrastructure for free, especially if you're doing the Terraform graph stuff. 2, it's reproducible. I think one of the most frustrating things about V1 is that I can't reproduce that environment on my box or anywhere. So you're debugging stuff that's like already out there. I think maybe this should be number 1. It's a really big selling point. And then number 3, it's extensible. It is really easy if you choose the tools that are cloud provider agnostic to switch your stack, what you're running on. I think a great use case we have is that we can give our setup, we can give Infratron and a base config to a team, and if they needed to test it with all Ruby apps or whatever, they can just plug that in, or if they need to develop, we had somebody do like a Kubernetes deploy, which I thought was super cool because I'm like looking into it. But he was able to do that with the base that we provided him and the tool that we gave. It's a very empowering thing, disposable infrastructure. So I guess I was not going to do questions, but I think that was not 8 minutes. So this was disposable infrastructure. You only built me up to tear me down.